Alright, so lesson number 5, we're introducing the composition of functions. So far we've done the sum, the difference, the product, and the quotient. This one's a little bit different because now we're basically subbing a function into another function. The function of a function. Once you see a few examples, I think you guys will think it's not too bad, but initially the notation might be a little bit tricky. We're going to start with some word problems just to introduce, and then we'll get into what you're going to see more and more later on. Okay, so part A. When a pebble is dropped in a pool of water, ripples in the shape of circles form on the surface of the water. The radius of the outer ripple is given by the formula r is equal to 0.3 t. R is the radius in meters, t is the time in seconds after the pebble hits the water. If the area of the circle is a equals pi r squared, combine this formula with the radius formula for the outer ripple to write a formula for the area of the circular ripple after t seconds. Okay, that's a mouthful. Anyways, we have the area of a circle. They want us to combine this other formula for the radius into one formula. So what do you think we can do? We need a formula for area. What we're going to do is we're going to take the fact that r is equal to 0.3 t, and we're going to replace the r in the area formula. So in other words, we're subbing a function into another function. So we start off with area equals pi r squared, and we're going to replace the r with what was given above, 0.3 t. And don't forget to square that. So this function has gone into this function. All right, so far? Okay, part B gets a little bit wordy, a little bit trickier. The 3.5 liter V6 2012 Toyota Camry has a fuel efficiency of approximately 8.2 liters per 100 kilometers. The cost of gasoline is $1.25 per liter. So for part A, the volume L liters of fuel used can be written as a function of the distance d kilometers traveled. Complete the following for liters in terms of d. Okay, so let's just go through, take a read, see what they're giving us. They say that we have a fuel efficiency of 8.2 liters for every 100 kilometers. Okay, so let's just calculate that, 8.2 liters. We're going to divide by 100 kilometers. This will give us the unit rate per 1 kilometer if we divide the two. That gives us 0.082 liters per kilometer. Okay, so if we're talking about just distance, we look at the function for liters, the volume. It's going to be 0.082, and that's going to represent d, okay, which is distance. So this is the fuel efficiency, or sorry, the volume. Okay, for part B, the cost, C, dollars of gasoline used can be written as a function of L. Complete the following for C in terms of L. So on this one, they're telling us that it's $1.25 per liter. Okay, so just 1.25 for every liter. So we've established two functions now. We have one function f of d, which is representing the volume, liters, and the other function g of L, which is representing the cost. Okay, for part C, we can find the cost of gasoline in terms of distance traveled by combining these two functions. So function L, function C. Okay, if we substitute the formula for the first function into the formula of the second, we can write C as a function of d. Okay, so what we're doing is, if cost was 1.25 liters, we can take the L and replace it with the function up above. So we have 1.25 L, and I'll use script but the L is going to be replaced with this function here. Okay, 0.082D. Because we want the cost as a function of D. So D needs to be in the formula. When you're taking a function of a function, that's called a composition. And that's what we've done here. We've composed the function for liters into the function for cost. So the word problems are a bit trickier because you really have to kind of pick through, dissect through for the pieces of information and create your own formulas. The next little bit is easier because they give you the formulas. They give you the functions. Alright, so for the next one, they're telling us that the function h of x is given by 2x plus 3. This can actually be thought of as two functions and two operations. Okay, so we're going to be looking at the first step, which would be multiplying by 2. The second function would be adding 3. Composing 2 would be putting them together. So if we started with an x value, and we multiplied by 2, this is going to be our f function. Okay, if we multiply by 2, x is now 2x. If we take 2x and we add 3, we get 2x plus 3. So let's just go through the ordered pairs here, the values of x. We start at 0 and we multiply by 2. What do we get? 0 times 2? 0. We add 3 to 0, we get 3. Next one, 1 times 2 is 2. 2 plus 3, 5. So we're mapping now. 2 times 2, 4. And let's map by adding 3. So 4 plus 3 is 7. So basically we're mapping the functions here. Okay, so the function f applied to x maps to 2x. In other words, the function f is the operation that we're doing. Okay, that's going to be f of x equals 2x. For the second one, operation or function, we're saying that we're adding 3. Okay, but we're adding 3 to the original function 2x, which was in the middle here. So the function g applied to 2x maps to the end result, 2x plus 3. In other words, g of 2x is 2x plus 3. But let's just look at these individual operations. What would you say f of x is? What are we doing? Multiplying by 2, so it's 2x. What is the operation of g? Just adding 3. So if we were to do that from x, it would just be x plus 3. So one stage, so the first step of the composition is f of x, which is 2x, or multiplying by 2. And the other function, g of x, is adding 3. If we combine the two, or we compose the two together, we get h of x, which resulted in 2x plus 3. That's an initial introduction to mapping. We're just going to practice a little bit more. But first I'm going to introduce the notation of composition. Okay, so if we're looking at the new function h of x, and it's described as a composition of two other functions, f and g, we can write it as g of f of x. Okay, notice that f of x is inside the brackets of g of x. So we're going to put the function f of x into the function of g of x. F of x will replace all the x's in g of x. And we'll go through a few examples to show that a little bit later. Okay, again it's read as g of f of x. And this is the other notation here. So if you see this little circle, it's not filled in. Okay, an open circle, that means composition. Again, it reads g of f of x. Okay, it's really important to note that just like the last example, how we did f of x before g of x, if f of x is in the brackets, we apply that function first, and then we apply g of x. Okay, so whatever's inside the brackets, you apply first. Let's take a look at the next one. So consider h of x, it's x squared minus 2. Let's describe this in words and think about what is happening to x first. Okay, we have x squared minus 2. What's happening to x first? Good, we're going to square x. So square x, and then what are we doing?
Subtracting 2.
Yep, subtract 2. So the first operation can basically describe the first function. Okay, it's squaring. And the second operation can describe the second function. Putting them together would describe the final function h of x. Okay, this final operation is combining f of x and g of x. So f of x, g of x. So let's go through it. If we started with a value of x, and then we applied the function f first, because if we take a look at the notation, what's inside? F of x. So f of x needs to be applied first. Okay, so if we look at x and then we apply f, what was f? Well, it's squaring. So then we get x squared. Then we're going to take x squared and we're going to apply the function of g, which was subtracting 2. So we get x squared minus 2. So looking at this mapping, we went from x, we applied the function f, and we resulted with x squared. What can we say f of x would equal? Any guesses? What's the function of f? What's the operation of f? Squaring. So it would be x squared. Say g of x squared is just what we resulted with here, x squared minus 2. But if we were just looking at g of x, what would g be? Okay, what's that operation? Minus 2. So if we're just dealing with x, it'd be x minus 2. This function here is basically h of x. Okay, because h of x was g of f of x. But what was f of x? It was x squared. So in the brackets we've subbed in x squared. And then if we apply that x squared to x minus 2, let's just take a look here. Remember, g of x is given as x minus 2. If I apply g of x squared now, this was my f of x, then all these x's are replaced with x squared. So we've subbed f of x into g of x. It's a function of a function. Okay, I'll just give you guys a minute, and I want to see how you do with the person you're sitting next to, or you can join up with another group if you want. I want you to try this last one and use the example from above. Your function is h of x equals x plus 4 all cubed. So think about which operation you would do first. Bed math might help. Brackets, so inside the brackets before exponents.
Add 4.
Classic number, example number 2.
Q. Pardon me? Well, actually, I might have to. I just realized she was supposed to. She's right.
So for part A, there's 2 operations that you need to describe in words. So that's why I said think of bed maths. Okay, what comes first? Brackets. What's inside the brackets? What operation? What is it? Adding 4. Good. So add 4. Then what? Cube.
Well, that's
Good.
supposed to be a word. X plus 4. X plus 4.
Alright, the function h of x is given as g of f of x. So if f of x is on the inside, that means it has to go first. So what would you say add 4 is? F of x or g of x? F of x, good. And g of x is going second, so what would you say cube is? G of x, good. So we've kind of jumped the gun on the next part, but that's okay. Just by understanding the notation, we've pretty much answered the question. Okay, so if x is mapped through the function f of x, just remember f we decided was adding 4. So if we add 4 to x, we get x plus 4. The second operation that we agreed upon was we would cube. So if we go from x plus 4 and we apply the function g, it will map to x plus 4 all cubed. So I think we can agree that when we map the function f from x, so f of x, we get x plus 4, which came from here. Then we applied g to x plus 4, and what did we get? What was the function of g again? Cubing, so we get x plus 4 cubed. And if we were just looking at the function of g, like I said, that was cubing. So if we're just looking at x to start with, it'd be x cubed. So these steps here, basically it's an introduction to skills that you would use in calculus, is mapping and using the chain rule. So is anyone here taking calculus? Coming up? Or in the future? So these skills might be helpful later. We're not going to use this too much in Math 30, but I just wanted to introduce it just in case. So let's take a look at the steps if we were going to figure out what the composition was. So first thing you want to do is rewrite the notation. For me personally, I find this notation much easier. You guys, you with me? So I find this notation much easier than this one, because I can see that f of x is subbed into the function g of x. Hey, you could know that there too, but I just find that's a little bit easier to sub into. Okay, so first thing you're going to do is just start with g of f of x. You're going to rewrite that. Next step is you're going to, whatever f of x was, you're going to sub that in. So replace f of x with the actual function. Then you're going to apply that function to g. So replace all the x's in g with the function of f of x. And then lastly, you just have to simplify. So expand and simplify. So let's take a look at example 3. We have two functions, f of x, 10x plus 1, and g of x, which is 2x minus 5. We have to figure out g of f of x. So step 1, we're going to rewrite it as g of f of x in a different notation. That's step 1 complete for us. Okay, second step is we're going to replace f of x. Well, f of x is given as 10x plus 1. So instead of writing f of x, we write 10x plus 1. So what has the x and g of x been replaced with? 10x. Good. 10x plus 1. So what's that x going to be replaced with? Pardon? If this x is now a 10x plus 1, what's that x going to be replaced with? 10x plus 1. Good. Just making sure. Okay, so we have 2 times 10x plus 1. Is that what you guys are saying? Thought so. And then don't forget to subtract that 5 at the end. Okay, sometimes people just sub f of x in, and then they forget about that last little constant. And then we just have to expand and simplify. Okay, so we get 20x plus 2 minus 5 is minus 3. So 20x minus 3. How are we doing with this? Is it a little bit tricky to start with, or are we doing okay?
Well, foggy. It's a little tricky.
Pardon?
It's tricky.
It's tricky? I'm going to show you a different way to do this. Okay, hopefully that will help. So we have g of f of x. Okay, g of x started out with 2x minus 5. But if we have g of f of x, what are all the x's replaced with? F of x. So 2 now times f of x minus 5. But what was f of x? Brandon?
That makes us 1.
Good. So we're going to just replace the f of x with 10x plus 1 and then subtract 5. If you want at the beginning, you can also write g times 10x plus 1. Or sorry, of 10x plus 1. And then we just expand. So we get 20x plus 2 and then subtract the 5. So 20x minus 3. Who likes this notation better than this? No preference yet?
Set aside.
Okay. We'll do a few more and see what you guys like. Okay, number 4, we have 2x squared as a function of f, and we have g of x is 3x minus 4. We need to find g of f of x. So step 1, we're going to rewrite it in the notation, g of f of x. F of x was given as 2x squared minus 1. So I'm going to replace f of x with 2x squared minus 1. Now g of x was originally 3x minus 4. But now we have g of 2x squared minus 1. So this x in g of x is now 2x squared minus 1. So this x here will also be replaced with 2x squared minus 1. So we get 3 times 2x squared minus 1. And don't forget to subtract that 4. Then we just expand and simplify. So we get 6x squared minus 3 minus 4. So 6x squared minus 7.
G of x. Now they're just being rude.
All right. Any questions? Okay, we're going to go on to g of x. So we start with rewriting the notation, g of x. So we're subbing g of x into the x from g of x. You guys love this? Okay, just a reminder, g of x was written as 3x minus 4, but now we're subbing g of x into the x. So it's 3 times g of x minus 4. But what was g of x? It was 3x minus 4. So g of x needs to be replaced with 3x minus 4, and then subtract 4. Last step, just expand and simplify. So we get 9x minus 12 minus 4. So 9x minus 16.
Junior class change.